This is a video to refresh you on polynomial long division and polynomial synthetic division, or to teach it to you for the first time if you haven't learned it before. To divide one polynomial by the other, we use a traditional division symbol where we put the thing we are dividing by outside the division bar and what we are dividing under the division bar. And we look at what do we have to multiply x plus 2 by to get x squared plus 7x plus 2. But what we do is we start out by looking just at the first two terms. We actually look at the first term. We look at the x squared and we look at the x. What do I have to multiply x by to get x squared? And it would be x. So we take x times both of these terms here and we end up with x squared plus 2x. And then I subtract this entire thing from what's above it. So x squared minus x squared is 0. 7x minus 2x is 5x. Then I bring down the next term. So it's very similar to the division you've done with numbers. Then I think, what do I have to multiply x by to get 5x? Well, I have to multiply it by 5. So I add plus 5 here. And then I take 5 times the quantity x plus 2, which would give me 5x plus 10. Subtract the whole thing, and that's what you're going to forget the most, is to remember to subtract the entire thing, both terms. 5x minus 5x is 0, and 2 minus 10 is negative 8. So I have a remainder here. Because I have a remainder, I know that x plus 2 is not a factor of x squared plus 7x plus 2 because it doesn't divide in evenly. So I can write that x squared plus 7x plus 2 is equal to x plus 2 times x plus 5 plus the remainder of negative 8. So that's, you'll see that in the notes. Okay, the next one, 4m cubed plus 4m squared minus 7m plus minus 3 divided by 2m minus 1. The difference in here is that my first term is not just an x. In fact, it's not an x at all, it's an m, but it has a coefficient in front of it. 4m cubed plus 4m squared minus 7m minus 3 divided by 2m plus 1. So I look, what do I have to multiply 2m by to get 4m cubed? I need to multiply it by 2m squared. So I take 2m squared times both of these things. So that gives me 4m cubed plus 2m squared. I subtract both of these. The 4m cubes become 0 when I subtract them. Then 4m squared minus 2m squared would give me 2m squared. What do I have to, and I bring down the next term, minus 7m. What do I have to multiply 2m by to get 2m squared? Just multiply it by m. So plus m. Multiply m times the entire quantity and I get 2m squared plus m, because m times 1 is m. Subtract, and I get negative 7m minus m is negative 8m. Bring down the 3. What do I have to multiply 2m by to get negative 8m? I have to multiply it by negative 4. When I multiply negative 4 times the entire quantity outside the division bar, I get negative 8m minus 4. Subtract the whole thing, and I get negative 8m minus a negative 8m, which is 0. Negative 3 minus a negative 4 is a positive 1. So once again, I have a remainder. 2m plus 1 is not a factor of 4m cubed plus 4m squared minus 7m minus 3. So I can say that 4m cubed plus 4m squared minus 7m minus 3 is equal to 2m plus 1 times 2m plus 1 plus 1. Wait a second, what did I just do? 2m plus 1 times 2m squared plus m minus 4 plus 1. So, yeah, I don't know what in the world I just did there. Okay, so if I were to multiply all this out, multiply these two out, and then add 1 to it, I would get back to my original polynomial. Okay, last one of the long division. Now this one is a little different in it illustrates another point is notice that we have missing terms here. We have an m cubed but no m squared or no m. So when we write this, it's important that we leave placeholders for those spots. So we're going to write 2m minus 1 outside the division bar, but inside the division bar it's 8m cubed plus 0m squared plus 0m minus 1. And we need to do that because when we bring down the next term, we always have to bring down the term of the next degree, and so we have to have something to bring down. So I start by multiplying. What do I have to multiply 2m by to get 8m cubed? I have to multiply by 4m squared. So 4m squared times both of these would give me 8m cubed minus 4m squared. So notice that we have something m squared to subtract the negative 4m squared from. Okay, notice I subtract both, which means this becomes a positive 4m squared because it's minus a negative. Then I bring down the 0m. What do I have to multiply the 2m by in order to get 4m squared? Plus 2m. So 2m times 2m is 4m squared. Negative 1 times 2m is negative 2m. Subtract the entire thing, and this becomes 2m minus a negative again. Bring down the negative 1. And what do I have to multiply 2m by to get 2m? Just multiply it by 1. So this becomes plus 1. And I get 2m minus 1. Subtract the whole thing, and I have a remainder of 0. So for the first time, I can say that 2m minus 1 is a factor of 8m cubed minus 1. So I can say 8m cubed minus 1 is equal to, and I've got an actual factorization now, 4m squared plus 2m plus 1. So if you happen to remember your factoring pattern for the difference of two cubes, which is a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. This fits the pattern. There's my a is the 2m, my b is 1, and it fits the pattern of that. But if I just remembered the first part, I could divide to find the second one if I don't remember it. Okay, that's your review of polynomial long division. Now, so we've only been dividing by binomials, but you could also divide by a trinomial. For example, I could have done 8m cubed minus 1 divided by 4m squared plus 2m plus 1. I could have done that. In that case, every one of these things I'm subtracting by would be a trinomial. I'd just keep subtracting trinomials, and I would end up getting 2m minus 1 as my answer. So I can go either direction with that. Now the second part talks about synthetic division. Synthetic division is a shortcut. If we have a linear factor, which is in the form x plus or minus a number. If it's in that form with just an x to the first here, then synthetic division is a faster way to do the division process. Now, two things. It's called synthetic division or synthetic substitution because it actually has two purposes. We can divide by a linear factor, or we can evaluate a number, and you'll see that we end up with the same thing. So first of all, let's look at the example here. If we're dividing x to the fourth plus x squared minus 20 by x minus 2. And we want to see if x minus 2 is a factor of f of x. In other words, we want to see, does it have a remainder of 0? What we do is we put 2 in this box right here. Basically, you figure out what the 0 is that is associated with this factor. The 0 is 2. That's the number that goes here. Then in the next row, I'm going to put the coefficients of the polynomial, leaving a 0 coefficient for any missing term. So I would have 1x to the fourth plus 0x to the third, 1x squared, 0x, and then minus 20. Draw a line here, and the first thing I do is I bring down the 1. So I put the 1 here. Then I'm going to take 2 and multiply by anything that's underneath here. So 2 times 1 is 2, and then I write it above here, and then I add. 0 plus 2 is 2. Then I multiply again. 2 times 2 is 4, and I write that here, and then I add 5. Then 2 times 5 is 10, add, that's 10. 2 times 10 is 20, add, and I get 0. That's my remainder. I draw a little bar there to indicate that that's a remainder. This was an x to the fourth polynomial. I divided it by an x to the first, so my answer should be an x to the third polynomial. And that's what these numbers tell me here. X to the third plus 2x squared plus 5x plus 10. So what I did was I just divided or factored f of x. F of x can be written as x minus 2 times x cubed plus 2x squared plus 5x plus 10, and there's no remainder. So I've actually factored it. Now, what if we put 2 into the function? So we say f of 2. Well, f of 2 would be 2 to the fourth plus 2 squared minus 20, which is 16 plus 4 minus 20, which is equal to 0. Notice that the 0 here is the same as the 0 here. This is telling me if x minus 2 is a factor, then I should know that 2 is a 0, which means if I put it into the function, I should get 0. It's amazing how that works. So these numbers turn out to be the same thing. So I could just figure out, rather than plugging the number in, I could do synthetic division and figure out what f of 2 is. So that's another purpose of synthetic division. Okay, let's see what happens with something that isn't a factor. You can see in your example that you don't turn out with a remainder of 0 here. Here we have x plus 3, or evaluate f of negative 3. So basically I'm putting negative 3 in here. And this is 1, 0, 1, 0, negative 20 again. I'm going to go through the process a little more quickly. Bring down the 1, multiply by negative 3, add. Negative 3 times negative 3, positive 9, add. Negative 3 times 10, negative 30, add. 3 times negative 30 is, negative 3 times negative 30 is positive 90, add, and I get 70. I'm going to make sure that I didn't do anything wrong here. That's what I'm supposed to get. Good. Okay, that's the remainder. So I can say then that f of x is equal to x plus 3 times 1 x cubed, 1x cubed minus 3x squared plus 10x minus 30 plus 70. Or I can say f of x divided by x plus 3 is equal to x cubed minus 3x squared plus 10x minus 30 plus 70 over what I divided by, which is x plus 3. If I were to multiply all of this by x plus 3, the x plus 3's would cancel out, and I would get the 70 up here. This is the same thing as if I have, for example, write 10 divided by 3, and I get 3 remainder 1. I would write that as 3 1/3 because I divided by 3, and so I write it basically as 3 plus 1/3. So it's the same thing as what I would do there. Now, if I evaluate f of negative 3, f of negative 3 is negative 3 to the fourth plus negative 3 squared minus 20, which is 81 plus 9 minus 20, which is 90 minus 20, which is 70. So look at that. I already figured that out. F of negative 3 is 70. That's the other thing I can do with this. Okay, last example. Put 2 in here. This becomes 4, negative 11, 8, and 6. Is this a factor or not? Let's find out. Bring down the 4. Notice that's not always a 1. 2 times 4 is 8. Add, negative 3. 2 times negative 3, negative 6. Add, 2. 2 times 2 is 4. Add, 10. Is it a factor? No, we got a remainder of 10. So I think you can read the explanation down there about what you need to see, what you got from there. But this is how you do synthetic long division.